Hey, welcome to my new electronics lab. I think the last time I did a video on my electronics lab must have been about a year ago or so. But this is my new setup here, and I will quickly walk through as to what I have in my lab right now, um, and also talk about some of the recent acquisitions of some gear, test equipment, and whatnot. Lately, I've been spending some time on building some RF related projects, especially this one here is an RF filter. This is a low pass filter I built, must have been 2 weeks ago now. It was a very gratifying experience to build this. And I'll do a separate video on how I built it, the tools I had used, and also the place where I kind of sourced some of these parts from, and I'll cover that later. And I've been also working on tuning this duplexer cavities lately, and this one here in particular is made by Motorola. So I've been spending some time on the RF side of the world lately. So in light of that, I have been looking at purchasing a spectrum analyzer, and after much thinking and noodling over, I went and purchased this 8594E spectrum analyzer by HP. I got a pretty good deal on this on eBay, and really happy with this purchase. There is one drawback with this equipment, and that is this does not come with a built-in tracking generator. Initially, I was hoping that I could get around that problem by using things like an RF signal generator. This is another equipment I had recently purchased. This is an SME-03, and it ranges between 5 kilohertz to 3 gigahertz. This is an excellent machine. It does the basic stuff, of course, like putting out a frequency and at a certain level, and you could do all that stuff, no issues at all. But this has got other stuff that you can do with. For example, it can do a sweep, so you could build an excursion of frequencies, and along the excursion you can set markers, and then you can set amplitude against each of those markers. And you could do a lot of cool things with it. Anyway, so I was hoping that I could use this in lieu of a tracking generator, and then using its output to come into my spectrum analyzer, and then tweaking the cavities on this duplexer, or testing the filters or whatnot. But man, that's a challenge, and because one, it's not real time, and it's a goose chase. At least for me, it was. For example, this particular duplexer has the tuning knobs in the back, and as you tune these knobs or turn and adjust these knobs, you want to see at least a close to near real-time view of how it's responding to frequencies, right? Without a built-in tracking generator, that's a challenge. I mean, it could be done. It could be done. I mean, don't get me wrong. You could use the RF signal generator as one example, and then you could use the trace feature and have it hold the trace and let it run a couple of times, a couple of iterations, and then determine the frequency response in that curve, and then go back and do any further adjustments if needed. But that's a lot of work and a lot of time of going back and forth, because it's a constant moving target, and without a real-time view of the frequency response, it's a challenge. Another option could be, instead of using an RF signal generator like this one here, you could buy a noise generator. A noise generator puts out a noise across a bandwidth, and so long as that band kind of falls within the scope of what you're interested in, you could very well use a noise generator as the source input to your duplexer as an example, and then have the output kind of run into the spectrum analyzer and get a close to near real time frequency response. But even that is not as ideal, if you will, than having a built-in tracking generator. So I've been doing some additional thinking and said, hey, you know what, I really like the 8594E. For one, it's a later model. It's got a lot of other features that the previous models do not have. So I said, okay, let's look for an 8594E and that has a tracking generator, which is what I did. So recently I acquired this one. This has an exact same configuration, but this has a little bit more options in it, and it also has the built-in tracking generator. So this is, I've already done a couple of tests with this machine as I was setting it up. But man, it makes a ton of difference, a day and night difference with having a tracking generator in your machine. So very excited about this. Again, both of these machines run at 9 kilohertz to 2.9 gigahertz range. And this machine works really well. Again, don't get me wrong, this is a fantastic machine even without a tracking generator. But if you're looking at doing any filter work or duplexer work, I think you would really want to look at one with a built-in tracking generator. It's a little bit more money, but I think in the interest of time and the amount of back and forth time you would be saving, I think having a built-in tracking generator is definitely worth the effort. That's in my opinion, at least. So that's a quick view of those machines and a little bit of a history behind why I have two. I mean, I will be, of course, putting this for sale because obviously I don't need two. So I'll be putting this for sale shortly on eBay. So hoping to recover some money back from that. And on this side of the lab, I have my Siglent equipment here. This one here is a SDG 1032X. This is a 30 megahertz arbitrary function generator. A very nice device. I mean, this has a ton of features in it, and this can also do a RF signal generation up to 30 megahertz. So if you're looking at doing any filter or duplexer type of work in the ham radio HF band, I think this might still work. No issues there. And this one here is my digital multimeter. Again, one of the common themes with Siglent, I've looked at Regal or Rigel or whatever you call it, and Siglent. I tend to like Siglent products better because one, they feel, I mean, again, I'm not an electronics engineer or a quality tester by any means. I'm a pure hobbyist, and from a hobbyist perspective, I feel like Siglent products are much better. I constantly try to test this with my frequency, with my reference counter here. This is my HP 5334B universal counter. This is my sort of like a reference frequency counter for me, and I use this to kind of validate the trueness of frequency output and whatnot. So this definitely holds true to what I'm trying to do. And so that's that. And here's the, oh, by the way, at the bottom here, this is my SPD 3303XE digital DC programmable power supply. This I've used it a couple of times. Works really good. I'll do a separate video on that later, maybe. So here's the HP8116A pulse generator. This is a 50 megahertz. This is also one of them, kind of a reference pulse generator units. It works really well. And also here's my LaCroix DDA 125. This is my oscilloscope. This has a, let's see if I can get a closer view of this. This has a this is a 1 gigahertz machine, and it can take up to 8 gigasamples per second for a single channel. But if you were to go all 4 channels at a time, it can do up to 2 gigasamples per second, which is still crazy fast. So that's that. And on this side of the lab, this is my Hakko 851 Pro. This is the latest soldering station. I used to have a Chinese-made soldering station for whatever 15 years. It finally died on me, and that gave me a good reason to upgrade. So very happy with this product. Very configurable, and I think it works really well, and very happy with it. All right, so I got, by the way, the soldering iron is also very efficient unit, and I got some extra tips for it over here. So that's that. Well, with that said, I wanted to first of all do a quick view of the lab. By the way, this is the DER EE. This is the LCR inductor / capacitor meter that I've used a couple of times for my filter related projects here. All right, so that's a quick view of the lab. I wanted to quickly show you as an example. If you look at here, there's a flicker, and there's a way to change that, to fix that. Let me also go here. For example, this one does not have a flicker. And when you first purchase this may be set up with the default sync. So let me show you how to fix this actually. Let me go back to normal, the way it's usually set up in when you first get it. And I don't know if you're seeing the flicker there. Yeah, there is. So the way you fix this is you want to change the sync from normal to NTSC. But as we do that, keep an eye on the date and time here, the HP logo up here, right? And also keep an eye on the margins around the screen and the display. So let me change this to NTSC, right? So you see what happened. First off, the HP logo is cut off and the date and time kind of shifted down here. And then the margin kind of went a little bit wacky, right? So there's a way to fix that. Yeah, the flicker is gone, but you also kind of ended up with some weird looking screen. I mean, if you were to work from here at this angle, you're not able to see this section of the screen very comfortably. You'll have to kind of snoop around and look at it and then go back, whatever. So the way to fix that is if you go into Cal, there's a Cal button here, and go all the way up to, let's see, 204, and 204. Let's see if you can see this. There's a CRT vertical position and a horizontal position, right? And then you go to your horizontal position, right? And then it says horizontal position 17 there, which is the default. Now you can use this knob here to turn this, right? And then as you can tell, it moves. and you want that, right? So now I work at this angle. Let's say that's a little, that position is a comfortable position. So and then you hit enter, which is this button here. You can't really see, it's at the very bottom. It says enter, enter. And then you can also adjust your vertical position if you need to, and then do the same thing. So that's the way I use it for video shoot, at least. But normally I leave it as normal, because I'd like to see the date and time on the top there. I don't know if there's a way to get around this, right? I don't know if there's a way to. I tried the vertical offset. Let me show you what I mean here. Let's go to 204. Let's go to vertical offset, right? So vertical offset doesn't do much with the logo, as you can tell. It doesn't do much with the logo, right? The logo is definitely chopped, but that's what that is. All right, so I'm gonna go back to config, and I'm gonna reset my display to normal, and I like to have the date and time on the top so it doesn't hinder my the plot area. All right. Okay, yeah, you do get your flicker back because obviously you're not in the NTSC refresh rate like this one here. All right, very good. So I thought I'd share that with you, a quick tip. And one other thing I want to close off: when you first get your machine, let's say you got this one with the tracking generator, you will want to do a calibration. There are two types of calibrations you will want to do. One is the all up, sort of a base level calibration. So you want to take a sort of a coax, a short run coax like this one, and then connect up the cal out to your RF in, and then go into cal, and then click on the cal frequency and amplitude option here. But before you do that, right, when you first power on your unit, you want to give it a few minutes for it to warm up. There's an oven in the spectrum analyzer, and it actually shows a message. It says oven cold, I believe it is. Wait till that message goes away before you calibrate. You want it to completely be warmed up before you start calibration for the best results. So anyway, so once you've done that, once you've done the basic calibration, you want to then do the tracking generator calibration. Again, use a similar cord, a short run cord, and then connect these two up, and then you can go into calibrate, and then go into, I believe, let's see, yeah, you see this page 3 or 4, sorry about the focus there, where it shows the calibrate tracking generator. That is the option you'll need. The main tracking, the main calibration takes anywhere between 7 to 10 minutes. It took me about 8 minutes or so. With this machine, it took me about 7 minutes. Once you've completed that, the tracking generator calibration took me less than 2 minutes. So it was fairly straightforward and quite fast. All right, thanks for watching. And again, I'll follow up with a few videos on using this spectrum analyzer with the filters and tuning the duplexer and whatnot, and I'll come back for those with those rather later. Thanks for watching, and we'll talk soon, and God bless.